Welcome to the Crazy Wisdom Podcast. I've got Ronnie Bird, and he is a data and AI executive with experience at Amazon and Microsoft. Welcome to the show.
Thank you for inviting me, Stuart.
So, data, I have been getting into lots of rabbit holes about knowledge management, information architecture, library science, and I've done a lot of episodes on data science. And the reason why I'm going down these rabbit holes is because of knowledge management problems, which I saw at the first institution that I worked at, all related to how do people get knowledge management? How do you do all of that stuff? Now the same problems seem to be appearing with agents and all of these other things. What is your general understanding of either the problems we've been dealing with for a long time with data and management of knowledge and data inside of organizations, and how is that changing in terms of the AI agents and stuff?
Well, good question. I think if anybody tells you that they know, I think they don't know, because I think it's changing really rapidly, and all of us in the industry are still learning what works, what doesn't work. But I think the general feeling, and this has been going on for a while, ever since I've started working on data, is to get, the ability for the stakeholders or the people who are actually looking at the data as close to being able to query it the way they want, get the insights that they want without any intermediaries. If you look at the arc, I think about 10, 15 years ago, everybody was talking data is the new gold and everything was really good. Then came the data lakes and all the tools that allowed us to process the data in data lakes so the data didn't get tied into specific tools, when the promise was everybody was going to be able to process and query the data and things like that. It turns out that there was a little bit of that because, suddenly departmental, areas within the companies or people within those companies were able to access the data a lot easier without having to go to, centralized data teams. But it turns out that actually, you do need governance. You do need some form of that. So over the last couple of years, I've seen a lot of, tug and pull between how much governance you can have on data lake versus how much data. And I think the big difference of what's happening now with, Gen AI, agentic, and all of that is it's breaking down the barrier even further of, like, let's say you do have the data, but still you need to have, understand a little bit of dashboarding and how to do that. You still need to know some SQL. You still need to do, or Python or whatever it is you're coding with. And I think agents are allowing people now to say, hey, I just want to see this data in this format with this dashboard, and I'm good enough with that. And you see a lot of, data companies exploiting that. You have, like, usual suspects like the hyperscalers, Microsoft, Amazon and Google, but you also have the Databricks, the Snowflakes, everybody racing to get easier way to individuals to go and query the data directly in English, and that's providing a lot of insights that, to line managers, to salespeople, to business stakeholders, to just go and ask the questions that they need. I think that's where it starts. Where it will end, I don't think anybody will know. I think agents may start to get insights that people were not familiar with. I mean, there was an interesting experiment I think we run at one point where we were asking kind of the agents to fill in the catalog for us, because we didn't exactly know where the data is. The most problematic situation with the data is you don't really know what is good data, what is bad data, what is data catalog or not, junk in, junk out, or data quality in. And so you can definitely ask agents to start cleaning that up for you. That's used to be like a very tedious job, and you start to see a lot of those behaviors starting to happen as well. But
Okay.
the rest is speculation.
What rest is what? Speculation.
The rest is speculation of where it would go. I mean, as they get smarter and smarter, I think we're going to see a lot more of ability to join different data or get insights that you didn't expect.
Okay, I love this because since the LLMs have showed up, few people talk about the prime benefit in my life there's not a lot of people, but it is overshadowed by a lot of the doomerism and all the viral takes and everything like that. But one of the main things that I find is that it teaches me stuff, and so I'm learning about what data is and all these things about data cleaning. And I was aware that data cleaning was this kind of crazy job, and now it's not so crazy, because essentially what data cleaning is it metadata? There's metadata. There's other forms of data. I mean, what is data? This is a question I love asking. There is no answer to it, right? Because it depends, right? What is data? But can we go into sort of like a what is data inside of the organization? Why is it so important to clean? And it feels like there's this haystack problem, right? Because there's the needle in this haystack. You need giant companies with thousands of people and millions of documents. And how do you find the specific thing right when you need it, right? That's the essential thing that everybody's trying to solve, right?
Yeah, I think, I've been working with customers over the years, and everybody goes through this transition of like, I have a lot of data, and what is the where's the value of the data? What can I get out of it? And a lot of companies and a lot of customers goes through this, process where they mature in their ability to process the data. There's a very famous, architectural pattern that's called the golden, architecture is called bronze, silver, and gold. People tend to refer to it where, bronze is what they call about it's just the data that I dump, right? It's, unfiltered, uncleaned, and things like that. Then silver is, you do some post-processing on it. You clean it up. You normalize. Not normalizing it is the right word, but in this traditional SQL sense, but it's more about, hey, if there's a user, ID, let's make sure that the user ID is consistent across all the fields that we're using. Let's make sure that there's a bunch of JSON blobs in it. Let's flatten them out a little bit to make it easier to query. If a lot of people tend to join two data sets, let's make sure that the keys are consistent. And then you have like the gold, layer that they call it, where it's like, okay, now these are very common questions that people ask, sales, I don't know, I'm just using sales, but it could be anything, right? I mean, that's a typical, stereotypical one, but it could be anything that you can imagine when you're doing log processing. It can be, you clean up all this stuff, you strip it from private information, and that's what's considered gold data. The problem, though, is doing that step now becomes the bottleneck for the person who's actually trying to query the original data, the bronze, data. You can count the data. So this now becomes the new, how do you say it, bottleneck. It used to be like the tools were the bottleneck, because if you didn't have access to the actual, I don't know, SQL database or Postgres or whatever analytics, tool you're using, or Lake, you wouldn't be able to get access. But now this is the problem, because now you don't know if you get access to the right data. So metadata becomes also important. And so that's what you've seen in the industry. There's all this catalog, kind of in the open source community, there's a catalog wars, if you will, where, different standards and different formats are trying to make, the catalog of reference, because that's now becomes really important. And catalog is what you call metadata, which is super important. Like, what does this data contain? What is this column about? What is this thing about? That still has not been settled. There's a lot of like different things, the big players, the Microsofts, the hyperscalers, and the very well-known open source projects are still competing for which one it is they want. You have Unity Catalog, you have the Snowflake Polaris, and so basically, that metadata needs to be cleaned up as well. And that sometimes tends to be a job that is delegated to line businesses. There's no central team doing any sort of cleanup. And I've seen different
interesting
companies take different takes on it. I've seen anywhere from large, well-known companies in South America and North America, trying to do this sort of like pushing down this catalog cleanup down to their own teams, because nobody really knows what data's coming in. And what I've seen, and there was a prototype that was worked out at one point, where they actually use an agent to say, hey, look, based on the patterns that you're observing of usage and missing on the data, can you please fill in the metadata for me? Tell me what you think this is, right? because they can, if you feed the logs to it and you can feed the queries to it, the LLM sometimes can make some smart inferences about what data is and how to join it and recommend ways to create these things. And so now people can use them directly to create their own metadata, to create their own silver layer, like they can start using it that way. So it's an interesting transition in that particular domain that I'm seeing.
Yeah, there's a lot that I can go into there. There's joining two data sets together. I love what you said about the bronze, silver, and the gold. And the bronze, we lose the access to the original data by cleaning the data. And so it reminds me of someone, I think actually it was another Argentine, Federico Lois. He gave us this excellent presentation on his thesis for databases where you just collect everything. And it totally blew my mind in the sense that that's what this information age allows us to do, is allows us to collect everything and make sense of it. And now the LLMs are coming in and actually doing that, but there's the ideal of doing that, and then there's the actual process of doing it, which is very, very far away from each other. I do a podcast with my dad called Stuart Squared, and in that podcast, he is convinced that Apple has the best IT in the world because the leadership of Apple basically knows all of these different things. I'm not sure whether he just kind of intuited that or whether he has actual access to it, but they just have really great IT. And this goes back to the way we started of knowledge management. Large companies, we got large companies who are essentially just these giant machines, and they have different sets of incentives that aren't shared with smaller companies. So a company like Claude or a company like OpenAI, they are scaling right now, but they haven't scaled. So they aren't dealing with the same sort of sets of conditions that a company like, Facebook or Oracle or all these companies that are mature companies that don't have those same incentives. So they're allowed to create these structures that allow them to do better IT. I'm sort of like going all over the place because this is such an interesting question for me. So if you have anything to say about that, please interrupt at any time, but I can keep on going. Where essentially, man, it's like then the LLMs are coming in and they allow us to make inferences on patterns, new patterns, but they also create a whole bunch of new documentation. And I'll give some really specific examples here. When I'm coding with Claude Code, I'm now just building these giant, labyrinths of complexity that I'm not a coder. I don't know what's going on in these things. It's just doing these things. And then it works. It works or it doesn't work. And if it doesn't work, I get it to go tell it to fix it. All of the knowledge management that traditionally would have done by large teams who would have documented all these different things, none of that exists. Like there's no observer who's in the middle of it watching it. It's like just me fooling around, but there's giant amounts of knowledge that have been created in that process. And this feels like it's going to be such an interesting question. A lot of the knowledge management and information architecture people that I talk to say ontologies. We are going to need ontologies, really, really strict data requirements with metadata and controlled vocabularies and knowledge graphs and all of this stuff, different stuff. And then I talk to my friends who are like at the leading edge of actually like using these agents. And they're like, the agents are going to do it all. They're going to basically do all of this knowledge management stuff. We just have to figure out creatively how to do that. I just got out of a conversation with a friend about this. And so there's these two different pulls, basically. One is sort of like tech company, technology will solve it all. Other people are like civilizational level knowledge management libraries for thousands of years. We have to go back to that. What do you think? Where are you in this side?
I know I'm trying to point to where if there's a question there, or you want me to just talk about my perspective on, or you touched a lot of topics.
Yes, I did.
I'm not an expert on all the frontiers of where LLMs can do well and cannot do well. What What I have seen though is LLM are an amazing way to compress a lot of the knowledge that they grab and all the alignment that they get in a smaller way, right? So think about it as a very efficient compression algorithm that you can actually ask questions and decompress only the pieces that you need in different ways.
Whoa.
But I have not seen LLMs do math really well. I have not seen them do that, and most of the time they resort to code, right, to some
Yeah.
tool to
Yeah.
respond to that. And so I don't know where I'm not an expert enough to know, and I know there's a lot of really smart people looking into this. And there's a debate, I think, in the in the research community around this of what is possible with LLMs, what not possible. And so, in your realm of would the LLMs discover relationships and logic in such a way? I don't know. I think they can. Uh, there's always this question about whether the LLM can infer it or he actually knows it.
Yeah.
Right. And so if it's known patterns that you're looking for, probably the LLM will be good enough, or there's like relationships that are similar in another domain that you can apply to this domain, maybe they'll find out. But I'm not sure about, the more logical sense of relationships. I mean, so we know LLMs are not good in some of
Yeah.
this math, as I
Yeah.
was saying.
Yeah.
So it's not obvious to me where that boundary is. The other thing I would say is this problem with ontologies and things like that is something I can tell you that the search engines has been dealing for about 10 to 15 years already. This is not a new problem for them. And they've been applying AI, not in the form of Gen AI, for a
Yeah.
long time. And the reality is, it's messy. It's not as clean. I mean, the tools definitely support you. The tools allow you to, like, otherwise it will not scale. So these companies use AI to scale these creation of these ontologies and things like that inside. I think even, Microsoft, they have a Bing, graph or something that they expose actually, which is their own ontology on the web and things like that. I believe they have it. And so, the more of that, the more obviously the LLMs will be able to go and query them and do the things that humans can do as well. But I don't know enough to tell you how that will behave. What I would do want to say is probably to your statement about, Anthropic or Apple, things like that. I think they will contest that they have access to the data. I think they pride themselves that they don't. So I think I would be surprised if anybody will come and say that they can see. I mean, the whole motto for a lot of these cloud companies is they cannot access your data. I know AWS cannot. I know Microsoft cannot. So that's a very big no-no, and these companies invest millions and millions of dollars to make sure that nobody but the user can access their own data. So I'll be like a little bit surprised if that statement were true.
Yeah, interesting, and that's a very good point. We can go into that, and it reminds me of the governance thing that you mentioned too, about which I also want to talk about, of this sort of access control. That was one of the most interesting things when I got started at a company as the director of knowledge management, as it was scaling from 250 to 5,000 people. While it was scaling, and I became responsible for all the knowledge management of this company, I realized that what they hired me to do was not in their interest to do because of this access control thing, where it's like, why does every Google sheet always default to not being shared? Well, if you're in an open organization, if it's your personal life, if you're sharing it with your friends, that doesn't make any sense. But if it's inside of an organization, it actually makes a huge amount of sense. And it feels like the reason why it's so difficult for me to go into AWS as a vibe coder and like figure out how to do all these things is because there's a huge amount of business logic that goes into it, of doing exactly what you just said about Amazon doesn't need access to all this data that they're providing. That it doesn't, like, it would be bad for them if they had access to all of this data, because that means that they're not giving privacy to these companies, and companies actually do require privacy. And so I don't know whether my dad actually said that like Tim Cook has insight into the consumer data that Apple has, but I think he was talking about the supply chains for all the manufacturing that goes into the iPhones and all of these different things. Like that's the level of IT that they have where they can just know all of these different things. Do you think that that's accurate? Like that they can, yeah,
I don't have
yeah,
comment on that. I really
yeah,
don't know. I wouldn't know anything
yeah,
about that.
yeah. So what in your world and your expertise in AI, what are you most excited about? What are you most interested in? What are you most afraid of? What are the things in your world about AI that are going on?
On AI, I'm really fascinated by this realizations that LLM had that they can continue to scale.
Hmm.
And I don't know how much you know about, and if you talk to anybody who's been, doing research on this area, the big insight for the, attention uh, paper and the resulting exploration by OpenAI was it allows you to scale up. And as they kept scaling up the training and feeding it more data, the model became almost, this very predictable graph of smarter, right? And learning more relationships that they weren't expecting. And I'm fascinated by, how far can they take it, and whether it's today, there's a lot of constraints about how much the model fits in memory, and there's economics around it, right? And then how much you can actually power it. So I'm fascinated a little bit by the choices of architecture that the LLMs have picked up, and whether there's one size fits all architecture in
Ooh.
LLM to do all the things that we want them to do, right? We already know that's kind of not true, because you see a lot of these fine tuning of different like models, right, for different tasks, which means that it's not general in the general sense that one model does it all. But today, for a large extent, people keep using the same architecture. There's obviously variations and things like that, and there's innovations that happen in these companies. But I'm just fascinated by how this will evolve and what will happen. I'm fascinated by this, new trend that some people believe is going to happen. I don't know if it's I mean, Jensen Huang just presented the Omniverse, I believe, like a couple of days ago in the SES, and how they believe that simulating the real world and creating models
Ooh.
for the real world, it's an interesting thing as well. Because probably I'm guessing here they're thinking, hey, there's models much more attuned to the realities of the physical world, and if you feed that plus other things, plus knowledge, what do you get out of it? So I'm really fascinated by that. Obviously there's the commercial aspect of it that I'm always interested in, like where are the real applications of it, versus where is the promise that the chasm of disillusionment, that we're going through a hype cycle a little bit. It's a real technology, it will stay, but there's obviously this, everybody wants to figure out where to use it. So I'm always fascinated by the scenarios that people are creating, and learning about them. That to me is super interesting.
I want to zero in on the one model to rule them all versus 1,000 different models. I think that's a really interesting question. It's something I've been trying to figure out myself as well. There's a great podcast with it gets into RLHF, reinforcement through learning through human feedback. And that was the company I was working for. I was working for a company called Invisible Technologies, and they helped OpenAI do their RLHF. And then in that realm, I found out about all these other ones. And there's a great podcast from the guy who's doing Surge AI, who I'm blanking on his name right now, but the CEO of Surge AI. I love his podcast. He's only done 3 of them. Every time I want to interview him, every time he does a podcast, I go and listen to it because he gives me this sort of like deep insight into this problem. And the last one he did, I forget who it came out about a few weeks ago. Previously he was talking about one model to rule them all, but he's doing RLHF. His company is supplying RLHF, really good RLHF, to all the major tech companies. And he's now of the opinion that it's not going to be one model to rule them all. It's going to be every single company has their own model. But what you said about fine tuning is really interesting because it's fine tuning on each of the tasks. And that is real. There are a lot of people fine tuning having small models, and maybe correct me if I'm wrong on any of this, that there are like small models that they're fine tuning that are task specific. But how does that relate to this model? And it's something I'm trying to figure out because I'm using Claude Code, but I'm using all these other ones as well. And they all do seem to be a commodity, except for Claude Code. Claude Code isn't being able to be replicated by their nearest competitor, Google. Like Google is actually honest about, like, a principal engineer at Google is using Claude Code a bunch to do things that they can't currently do, and they're talking about the harnessing. I know I'm throwing a bunch at you again, but like one model to rule them all, a whole bunch of different models, and then this fine tuning thing. What are your thoughts there?
Uh, I'm definitely not one of those ML experts, I
Uh
think,
huh.
or they're frontier labs. I mean, that's a better question for those who work there. I'm glad enough to be able to rub elbows with them and learn from them, but um my personal opinion and what I'm observing a little bit is the answer is no. There are situations, and sometimes it's not because the model is not smart enough. Sometimes it's just economics.
Mm.
Sometimes I just need an agent to tell me whether, I don't know, I'm making this up scenario, but let's say all you want to do is to say, I think this part is defective or not defective. There's probably better ways to do this, right? I mean, I'm not sure you want an agent for this, but let's take that hypothetical scenario. You want this to run in low milliseconds. You don't need like the full tokenization thinking. You don't need a lot of things. You just need enough to deal with corner cases and edges that probably standard coding cannot deal with. And so you need a smaller model, smaller weights. One of the things about the models and what people probably see, like the differences between, Opus and Claude and context windows and all those things. I mean, if you read the literature and the well-known optimization techniques that, when you use them, you can process faster, right? Faster input tokens and output tokens per second, faster time to first token. And so sometimes it's just economics. Sometimes you just want a smaller, simpler, model with smaller weights just to do
Interesting.
this one task, right? Sometimes you may want, a very specific, I don't know. I can only presume the military would want different terminologies and different things, right? They may not want the very nice, LLM. Oh, you're right, and things like that. They may want something like much more accurate and warlike terms that I don't know where you would train them, right, to respond like that. So, I'm not saying that's exactly. I'm just picking
Yeah.
very extreme cases to highlight that I'm sure industries will have a plethora of those things, right? I mean, I imagine medical industry will also have their own specific terms then and way to speak, and that a generic LLM you can coerce it, I think, with a prompt, but TBD. I don't know. I really
Yeah.
don't know. I feel like, yeah.
The and it gets to what I've been wanting to ask you too, which you said you're interested in, is the economics, because you're dealing with these large companies who are essentially like, the economics of the tokens are really important. The economics of the tokens are not so important for me because I just got onto the Claude Max subscription, so I'm just like maxing out my tokens for my individual use cases. I've thought a bit about it because I've now built apps where I get an API access and it gets me some tokens, and it is either more expensive or less expensive. But when you're dealing with a giant company who are plugging into these APIs, dealing with these economics, where it is it's an expensive technology, right? It is an expensive technology to
It is
implement at scale.
expensive. It is expensive still. I feel in order for it to take off, two things need to happen. The price per token needs to drop dramatically for these. Like it depends on. I guess it depends on how you use it. Like if the future of agentic, where agents are intercepting all of the API calls that a
Whoa.
business is doing, the latency needs to drop to single digit milliseconds, right? Or very low tens milliseconds, right? And the amount you're paying per token is has to drop. That's why you see some of these open source, self-hosting models are attractive to some companies, especially at scale, right? I imagine, and I think that's why Meta is so, for
Interesting.
them, my knee jerk reaction for why Meta it's important to have their own LLMs is because I don't think they can afford to have paying every use within a
Yeah, of
social
course.
network,
Interesting.
generate images, generate videos, respond to queries, to do all that. I don't think they can go and pay OpenAI and Anthropic for that. They have to have control of it. They have to own it in their own data centers. I think that's my knee jerk reaction. It's interesting to see what ByteDance does with it, because I think I don't have any insights to this, but my guess is that's where Oracle is going as well.
That's super interesting. Well, that just gave me a bunch of questions about ByteDance and Oracle, the relationship between those companies now.
I don't know too much about it, so
Well,
I cannot.
and that's a far out. And there's the data center question, because I have looked into Chinese data centers. There's the Chinese data centers have ran into a problem recently because they overbuilt. So they have huge amounts of capacity. Some people think it's because they built a bunch of open source models that have really good architectures. But those are all, there's a question about token and latency uh, in these large companies that, and this gets into what we were talking about before, where you just mentioned the Jensen Huang and the physical AI, because real time, it's got to be in real time, right? If for this to be intelligent, it needs to be real time, and it needs to reason, and it needs to do all of these other things. And this goes into what Jan LeCun says about current models, is they just don't do any of that. And everybody's trying to create boundaries around it. And you accurately said about the code is the boundary, and not math. So man, okay, so better, faster, cheaper. What what do you think about the the future of enterprise usage? Are you pro open source or anti open source? What are your thoughts on open source, and how much of it will be?
And I'm in favor of open source. Like, there's nothing wrong with it. I think there's an interesting relationship. There's different reasons for open source. Let me tell you, it's not always like just the Linux version of open source I want to do good. Sometimes it's I want to be able to commercialize this easier, and so giving open source gives people. So there's after working with open source, let me tell you, working with open source for 15 years, we contributed to a lot of open source projects, within AWS. I was very, was a representative for a lot of those open source projects, big ones. And I strongly believe in it as an idea, and it serves different purposes for different, scenarios. I don't know enough about the open source models just yet. For L, I think there's they use the term open source, but I think there's just different connotation to it. Open source in a lot of these other scenarios is about, if I have a bug, I can go and fix it, right? Or I can go see the code, or I have a very quirky scenario and I can go do it, because my engineers can go do it. The open source of these models is like, you're really giving me the architecture, which architecture is not, it's interesting, but it's not like, it's definitely interesting. So don't get me wrong, from a research perspective and from understanding it, really cool. But I don't think that's where a lot of people go and tweak it. I think what they mean by open source is they mean the open weights. And open weights is a different thing, because open weights, what it means is you can, and when you have the architecture, you can fine tune that model to your own, content. If you don't have access to the weights, you cannot do anything. Like, you have to start from scratch effectively. And so you can distill, models, you can fine tune them, RLFHF, I always get the acronym wrong.
But without the weights,
you can do open weights. You cannot do that with Claude. You cannot do that with OpenAI and things like that. So I think that's where it is. And I think a lot of agentic use cases will use them. Like, There is definitely a tension. There's definitely a tension. Like, and for example, I'm always, just to put you in context, where I think there's an interesting tension and why I understand there's this debate about open worlds and not open worlds and whether it's good or not good. I think the question is, um, it's interesting from an understanding of the frontier where it's going. From a commercial point of view, it is, until there's nothing better, this is the best thing that you can have. And this is commercially viable and it's valuable and people are willing to pay for it. But there's problems with it. Like,
Ooh,
for example, take the iPhone. If you take the iPhone, it's very surprising to me that Siri is still stuck in the past.
yes.
Why have they not upgraded it to an LLM like thing? Alexa is just starting with Alexa Plus. I'm lucky enough to have worked in AWS and have early access to Alexa Plus, and it's much better than the former Alexa. Siri feels stuck that way. And the problem is you cannot fit some of those models on the phone. You cannot have the
Yeah.
power and the memory to do it. So the conversation about what is possible is interesting, but if I cannot fit it on my phone because the architecture on the model doesn't fit the power consumption and the memory constraints that I have, and Apple is very strict about what leaves the phone and doesn't leave the phone, does it, I don't know if it's it's a philosophical debate. It's not a commercial debate anymore, and until there's nothing that beats it. And I think that's the interesting thing I alluded to before. The attention paper and everything that OpenAI did was not so much as revolutionary in terms of like, oh my God, look what it can do. What they figure out is how to scale it in an economical way.
I like that.
I think that is the insight, right? And if you read the attention all you need paper, they're basically saying the outer regressive model that used to exist for many years, like BERT and all these things, they were good at some of these things, but they realized that they can make them better and scale better. And by the moment they did that, that's where it all exploded. So until they don't find a model that scales better or shrinks better or do things better, I think they might be able to do it. I don't know the latest research, but that's
Yeah.
that's my perspective on it.
And there's a lot going on about, there's a lot of hype right now about continuous learning, which I think goes into your point. I don't know enough about trying to separate the hype from the reality, which is a constant battle for me in this new world. What you said about Alexa is really interesting because I have now gotten my Seed Studio 4-field microphone, and I'm taking my vibe coding tools to go get Claude Code and Codex and all these other ones to code this, take care of all the software stuff. And it was a really funny story because I was like, okay, I'm going to go create my own version to see about it. And then I found out there's a software called Home Assistant. And Home Assistant plugs into Amazon, it plugs into Google, and Google already kind of put their conversational AI into that software. So I was going to go like recreate it on my own, hacking together all these different things, but I found out it's much more simple because they're doing it. Why doesn't the Apple have this? It's a huge, I had to vibe code my own application to get outside of Apple's horrible transcription, which was state of the art only 3 years ago. I think you're right. I think it's like small models on the phone don't work. It's not at that point. I think Apple's being coy right now. So I think that they kind of made a huge mistake, and now they're doing a whole bunch of stuff that they're not talking about. And I think one of those things is finally going to improve that. But for now, they're really far behind. And I bought an Apple phone when I should have stuck with the Google phone. Now,
I don't really know. There's probably a lot of variables and constraints Apple goes through. I mean, they have an incredibly high bar, so they may want to make sure it's really, really working. They may not want another, Apple Google Maps situation that happened many years ago. Like, it's below bar. They do. It's well known that security is top concern for Apple. So it's well known that probably they don't want anything leaving the phone.
And they're insecure, right? The LLMs are insecure.
All the inference power, you need a lot of memory. You need a lot of memory bandwidth and a lot of memory to do inference. So it's going to be interesting to see. I think the hardware space is changing a lot. The majority of the money is on inference. The majority of the commercial money is on inference. And so you're starting to see these, approaches where I think the latest Grok, company. I don't know if
Yeah.
you read the IE that NVIDIA bought. I didn't read all the fine print yet. It's not super obvious to me as I'm not a hardware engineer, but it sounds like it was a play for IP around inference, which um, it's funny. I think to think that GPU are specialized things, but they have not become specialized enough for inference. They're too general for inference, and so
Whoa.
they have to really buy into like even more specialized. And it's always interesting to see what's going on in that domain. That to me is amazing. What's going on, and the interplay of AI and hardware is going to be an interesting place to watch what's going on.
A really interesting point about GPUs are not specialized for inference, even though they are a specialized thing. There are something that is specialized for graphic processing, right? But
They're
yeah,
specialized for a lot of things, and matrix multiplications and and matrix operations is what they're really good at. But it's you can do. I mean, there's well-known techniques. Again, I'm not an expert by any means, but if you look at inference, you can do downsampling of floating points, and so the less floating points you have, the faster you can do, the cheaper the hardware becomes, and things like that. Versus GPU can do like very, very precise floating point operations, which is very powerful during training, probably. And there's all these techniques. I mean, I was doing reInvent. There was an interesting talk by somebody in NVIDIA I was presenting to the audience, and it was really interesting to see all the techniques. I mean, I think NVIDIA will dispute my statement, and I think maybe OpenAI will dispute it because I think they're a heavy user of GPUs. I don't really know. And so I think there will be a dispute around that. But I think if you read the tea leaves, it sounds like inference is where the energy is going to go. And but for NVIDIA, I'm sure there's execution wise, they're
yeah,
they're making really smart decisions and really good execution. So I'm sure they're going to catch up enough and produce something. And by the way, graphic processing unit is a misnomer anymore. I don't know if you ever seen one of these, Blackwells
no,
or things like that. These are not the chips that go into your computer. Okay, these are very,
interesting.
very different beasts. The very, very big racks and interconnects and cooling. And these are not. I mean, you can say yes, the technology underlying and underpinning it is very
Interesting.
similar, but the massive dies and interconnect and bandwidth and bus that they have and everything is just it's just something else. It's
Oh
very
man,
different.
that just gave me an insight into the sort of the supercomputers and how the super because what we've done with the GPUs from is we've networked them together into these large data centers. And instead of one giant supercomputer, we have one giant data center with a bunch of things like you just described, which is really interesting. So I know we got about 10 minutes left. I want to go into this inference world, specifically from the inference commercial and economic side of it, because what I believe the Chinese models have done is they did do this open weight thing that you described, and they have allowed for anyone to run inference. So there's a bunch of new companies that have sparked up. I think CerebraWorks, or there's a whole bunch of inference companies now that provide a bunch of inference. What is your take on this inference and memory thing that you described? Where is that headed? What are you most excited about? What are you anxious about?
Again, this to me has to do with I think the industry will invariably move into optimizing this part of the stack.
Yeah,
Okay. And they will go across the board. Like if I've been working on database internals for many years now. And if you look, and again, I'm not a PhD. I was lucky enough to work with a lot of very, very smart people in the database world. And what you notice in the database world is you started with some of the very basics, and you start optimizing across the stack. You start optimizing the inner loop of execution, which is called operators in databases. You start to leverage. I remember when SIMD instructions on Intel came out, they came out, and for many years they were not really used, but then databases eventually picked it up. You started to see columnar versus row level. You start to see all these technologies really to optimize databases, performance. And one aspect of it was the optimizer, like converting a SQL query into the more optimal plan that you can ever have, because it gets compiled. And people don't think about it anymore. And most databases run incredibly, incredibly fast, and you don't think about it. I think the inference has to go through that process still. I mean, and you see it. I think the DeepSeek paper, the DeepSeek, there were two papers, and one of them talked a lot about how the folks optimize the pipeline execution. So that was kind of the inner loop of execution. How they take leverage of the memory bandwidth, the pipelining operation, downsampling. There's a lot of techniques that they were exploring, but that to me was just, the analogy in databases, just the operator inner loop. Like, how do you can do what you already have to run it really fast? And I think hardware and software will go hand in hand there. And so it's very interesting to see. But to me, the architecture is the real is a real problematic thing in my mind, because in databases, the inner loop of testing new optimization techniques, where a lot of the gains used to come, was to change the query plan, to change the shape of how you're executing and what you're executing. You have like basic operators. In the case of LLM, you can't really change the architecture that easily, because the moment you have to change the architecture, you have to train it again. And training is very expensive to do. It's hundreds of millions of dollars to do. And so it's almost like I don't know, I don't have insights into this frontier, labs, but if you look at the open weights model, it's not like anybody can come and change a lot of the architecture of what they do. Like, if you look at, for example, Llama and OpenAI, when ChatGPT was public, Llama had this there's the multi-head attention, and Llama had this grouped attention and things like that. And the reason why they do it is just for performance and optimization technique. That's the only reason. Like, they discover this mechanisms in which, and I think if you listen to some of the podcasts, from some of these really smart researchers, they don't really know what some of these things work. I mean, there was an interesting podcast by Daniel Amodei, where he said, like, when he was working at Google, like, he was trying something out, and and he was trying it, and then he was training it, and then the result was really good. And it's not really obvious that they really understand. It's almost like, I mean, there's definitely research around it, and statistical analysis of why one thing in one space mapped to another vector space and things like that. They definitely know what they're doing. But there's a lot of these techniques that they're trying them out, and it kind of works, and you don't lose fidelity. But what it kind of works and no lose fidelity makes a lot of difference from a performance and cost perspective. And that loop is very, very expensive to do. And so my fear, and this is where, I mean, maybe LeCun and all these guys are going, is like, and it goes back to the beginning, is how do you change the architecture? What architectures are scalable in a way that's commercially viable? And the only one it seems like we know as of today is the one that I think, the Anthropics, the Geminis, these guys are doing. And I do not know what else is coming. And so I think that's going to be like very interesting to see what's going on. Even Nova, like take the example of Nova for AWS. They build it in such a way that is very easy to customize for agents. They say, look, for doing agents, you don't really need all these very smart, very complex model. You need a very simple one, because you want really milliseconds, things like that. So I think that's, to me, is I don't know if I digress from your question, but I think that's
that was great. That was inference architecture. The loop is hundreds of millions of dollars from the
trying.
It's that
testing an idea to whether it's good enough, and that doesn't that is very unique to this.
What industry? Yeah, it's not nowhere else. Right? Is there anything else like that in your mind that exists? Like, there's nothing else.
Rockets, interesting. airplanes, right? I mean, like you don't just go and try a new commercial engine out of the
Yeah.
blue. Like you slowly, incrementally try something out. And so my only fear is like we reach this uh not cul-de-sac, but we reach it may be a very long cul-de-sac. It may be like, all that we ever need. But if you hear the argument in the community, some of them are saying, well, maybe not. Maybe there's other ways to do this. And we have to
But
go and explore them.
but now we've got a giant ecosystem that's all built on those things, basically. So
It's going to be very hard to disrupt. Like, the scenarios of I want to like scenarios of summarization, right? I
yeah,
mean, I don't know how better you can get at summarizing things.
yeah,
Help me summarize this content, help me write this content in a little bit of a better format. Help me support cases,
yeah,
law, sweep, like all these scenarios. This is a killer app. Like you're not going to go I don't think there's a need for anything much sophisticated, more sophisticated and better. Sure, you can fine tune it to your scenario. But that works incredibly well. To your other questions about agentic and pattern recognition and the more sophisticated way we would like the agents to go, I don't know.
man, that's really
It's
interesting.
not.
I think we just mapped out the cliff of where if the hype. I mean, there's so many things, but we'll save that for another podcast episode. Next one in Spanish. Do you write about this anywhere? Are you writing about these
Huh?
things where anybody would
No,
be able
no.
to find it?
I'm busy. I'm busy enough trying to make them run with 99.9% availability and making them faster. I haven't thought about it. Let me think
So
about
those are the
that.
two things
Okay.
that you really focus on: is 99% availability and making them faster, basically.
My job is to make sure that this is no, I'm not just that. At the
Okay.
end of the day, the job in AWS was to make sure that Anthropic models can run. Yes, they can run very efficiently in our resource. It's a lot of resource
Yeah,
problem.
yeah, yeah.
It's like, how do you run Anthropic model with the right resources, with the maximizing utilization, with the best performance that
Yep.
you can get, and also making sure that when Anthropic launches a new model, it's available the same exact day in AWS. And there's a lot of engineering, well, just general engineering that needs to happen through that. Plus you have all the other things that you need to do in order to make performance faster and make it a viable product, right? So
Well, thank you so much for coming on a show. If there's somewhere you want people to reach, we can put it in the show notes later. But thank you so much.
thank you very much, Stuart. I appreciate it.